So often we're presented with a polynomial, may look like this, 6x squared plus 9x. So here we have two steps sort of mentally. We first want to identify the GCF, the greatest common factor, and then factor it out. And then you're going to have, often you'll have parentheses with something left over. So here we have a binomial, two terms. So what is my GCF? So what number will go into both 6x squared and 9x? Well, 3 will. And then do I have a common variable in both terms? Well, yeah, x. Notice it can't be x squared, I don't have an x squared here. Now, if it helps, you can certainly write this out as 6, maybe x times x, and then 9 times x. You can draw this out. You could write this out. You can, do you remember doing little factor trees? So 2 times 3, x times x, and then 3 times 3, x times x. And we see we have common factor. Sorry, did not have this other x here. We have a common factor here of 3 in both terms, and just one of these x's. So that's why it's 3x. Now, normally we don't do that. Maybe the first few, it's not a bad idea to do if you don't quite understand how we're doing that mentally. Okay, so now this is a two-step process. So now we actually want to factor that out. So we're going to pull that out to the side, and then I can put a parentheses every time. And then what is left? When I pull out a 3x, let me use my factored form here. When that's removed, what am I left with? Well, I'm just left with 2x. Plus, just bring down your plus sign. When I remove this 3x, what am I left with? I'm just left with the 3. Now, when you're first learning to do these, I strongly recommend that you go ahead and check this. So this is the final answer. But go ahead and check it by using the distributive property and multiply that out. So 3x times 2x, so this is our check here, is 6x squared. And then 3x times 3 is 9x. And we got our original expression. So it's definitely worth at least mentally checking to make sure you did that. Doesn't mean you're 100% right, because you could have made a double error. Or often what happens is students don't pull out the greatest common factor. Maybe they just pull out the 3 or just the x. Okay, we'll get some more practice here on these examples. So factor 8x cubed minus 4x squared plus 12x. Pause the video here and see if you can do this one. Welcome back. So what number goes into each of these? I usually look at the number first. Looks like 4. It's my greatest common factor between 8x cubed, negative 4x squared, and 12x. We certainly can't have any number bigger than our smallest number, right? So I couldn't choose 8 because 8 doesn't go into 4 evenly. Okay, so how about my variable term? Well, it's going to be an x. Again, I can't pull out anything bigger than my smallest x, number of x's. I only have one x here. I've got 2 x's here and 3 x's here. So that's my first battle. Find that GCF. Now, let's pull that out. Parentheses. What do I have left? When I remove a 4x from 8x squared, what's left? Well, the numerical part is 2. I remove 1x from 3 x's. I'm left with 2 x's. So that's x squared. Minus. What am I going to have here? Well, the 4 is removed, and one of these 2 x's is removed. So I'm just left with 1x. Plus, I removed a 4x, so that x is gone, and 4 times 3 is 12. Again, let's check this. Distribute through. Here's my check. 4x times 2x squared is 8x cubed. 4x times a negative x is minus 4x squared. And 4x times 3 is 12x. Notice I get my original expression. I'm pretty confident that I got that one right. Okay, how about this next one? Factor 15a squared b cubed c plus 20ab squared c cubed. Okay, so again, look at the numerical part first. So it looks like 5 goes into both of those evenly, so 5. And then what about my variable term? So I've got a squared and a. Well, it can't be any bigger than the smallest number. So we have a, and then b squared. And then I only have one c there, so I can't go any bigger than that. Okay, so 5ab squared c. So parentheses, what do I have left? So I'm left with, numerically, I've got a 3. And then I pulled out one of those A's, so I'm just left with an A. I pulled out two of those B's, so I'm just left with one B, and the C's no longer there. Plus, pulled out 20 divided by 5 is 4. And then that A is gone, the B is gone, and I'm left with one C. These take practice. Once you do a few of them, they're not too bad. We're going to check this by distributing back through. And I'll be honest, sometimes the checking really helps reinforce how we even do this, how we sort of pull apart this. You know, in the last unit, this is what I gave you. I'd give you something like this to get this. Now we're going the other way, which is a little bit harder. So 5 times 3 is 15. Let me use a different color. So 15, and then A times A is A squared. B squared times B is B cubed. And then C is just a C. Plus 5 times 4 is 20. A, B squared, and then C to the 1 times C to the 1 is C squared. And I have been known to catch my own mistakes in here when I'm going too fast. So that looks good, though. So negative 14x cubed plus 21x squared. So we've got a couple options here. It's easier, and we won't do this per se in this class. We might, but not in this lesson here. We often don't want the first term here being negative. It just makes the arithmetic a little bit easier when we're actually going to, there's actually another step we can do on many of these, particularly the single variable ones, where we're solving these. It ends up where we end up having to graph them, and then we solve to find solutions. We're not doing that in this lesson, in this unit, but that is something that we're foreshadowing. So to make that easier, we often want to pull out a negative factor. So when this first term is negative, notice all these, I've kind of been nice to you, and all these are written in standard form, descending order. I want to pull out a negative factor. So what negative number goes into both 14 and 21? Well, a negative 7. And then what am I left with? Well, let's look at the variable term. Looks like I have x squared. Okay, so negative 7x squared is what I'm factoring out. When I pull that out, what am I left with in this first term? Well, 2x. And then I pull out a negative 7 from a 21, so that's going to change that back to a negative 3. Again, let's check that. So negative 7 times 2x, negative 7x squared times 2x is a negative 14x cubed. Negative 7x squared times a negative 3 is a positive 21x squared. So that checks out. Looking good. There's my answer. All right, let's look at this one here. Factor 5x cubed minus 7x squared plus 3x minus 2. Get up a little bit. Okay. Look at the numerical factor. Can I pull out anything numerical? So get 5, 7, 3, and 2. Those don't share any common factors other than 1. So I guess I can put a 1 there. That's not, all I have is a 1, and I can't pull out a variable either, right? Because I've got x cubed, x squared, x, and then nothing. So GCF, when the GCF is 1, we call this prime at this stage. Now, later on, we may learn that we can actually factor this by doing some grouping. But for the GCF, if we can't factor it out, we'll call it prime. Really, the prime is when it can't be factored at all into any binomials or anything like that. So